Hello and greetings to everyone. We are to answer the following questions. For question 1, find the dimensions and units of the following. For question A, we have a pressure. We take down a solution. A, we have a pressure. Pressure is simply equal to the force per unit area. Simply means the dimensions of pressure will simply be equal to the dimension of force all over the dimension of area. Now we have to find the dimension of force. So force is simply equal to mass times acceleration. That means the dimension of force will simply be equal to the dimension of mass times the dimension of acceleration. This will simply be equal to the dimension of mass times dimension of acceleration. You know, acceleration is simply velocity over time. Dimension of velocity divided by the dimension of time. This will simply be equal to the dimension of mass is m in square brackets times the dimension of velocity is simply L times t to the power -1. We get to divide this by t. This will simply give us m times L times t to the power, you take -1 minus 1, which gives t to the power -2. From this, we can write down the dimensions of pressure. Dimension of area is simply equal to, we take dimension of length times the dimension of length. So this will be equal to L times L, which is simply equal to L to the power 2. So this will give us the dimension of pressure to be equal to, we are going to insert the dimension of force, which is this, then we divide by the dimension of area, which is this. So this will give us n times L times t to the power -2. We get to divide all this by L to the power 2. This will give us n times L times L to the power -2, this one the denominator, times t to the power -2, and this will be equal to n times 1 minus 2 gives us -1 times t to the power -2. This is the dimensions of pressure. Now we can write down the units. The unit of pressure is, we are going to replace m with the unit of mass, which is kilogram. We replace L with the unit of length, which is the meters per meters. We replace T with the unit of time, which is seconds per second squared. The units of pressure is simply kilograms per meter per second squared. We move now to the next one, which is B. For B, we have energy. B, we have energy. Okay, let's assume it is kinetic energy. Kinetic energy is simply a half mv squared. That means you take a half of the mass times the velocity squared. This will be equal to a half times the mass times the velocity squared. A half is a constant which is dimensionless. Simply means the dimension of energy will simply be equal to, you take the dimension of mass, you multiply by the dimension of velocity squared. This will give us the dimension of mass, which is m. We will multiply by the dimension of velocity, which is L. T to the power -1. Remember, we have to square all this. So this will be equal to m times L squared times t to the power -1 times 2 gives -2. We can express this as m L squared t to the power -2. So this is the dimension of energy. Now we can write down the units. The units of energy is, we are simply going to replace m with the unit of mass, which is kilogram. We replace L with the unit of length, which is meters, then this is squared. We will replace T with the unit of time, which is second to the power -2. Therefore, the units of energy is kilogram meter squared per second squared. We move now to C. For C, we have a momentum. Momentum is simply equal to take the mass times velocity. It's a vector quantity. That means the dimension of momentum will simply be equal to the dimension of mass times the dimension of velocity. And this will be equal to the dimension of mass, which is m, times the dimension of velocity, which is L, times t to the power -1. So this will be equal to m L t to the power -1. Now, knowing the dimensions of momentum, we can write down the units of momentum. The unit of momentum is, we are going to replace m with the unit of mass, which is kilogram. We replace L with the unit of length, which is meters. Then we replace T with the unit of time, which is seconds to the power -1. Therefore, the units of momentum is kilogram meters per second. We move now to question 2. Question 2, we have given the equation F equal to G m1 m2 all over r squared, where F stands for force, r for distance, m1 and m2 for masses. We are to find the dimensions and unit of the quantity G. F is equal to G m1 m2 all over r squared. First step, we are going to start by making G the subject of formula. F can be expressed as f over 1. Cross multiplying this will give us f r squared to equal to G m1 m2. Next step, we are going to divide both sides by m1 m2. F r squared divided by m1 m2 will be equal to G m1 m2 divided by m1 m2. At the right hand side, m1 will strike m1, m2 will strike m2. Then we are going to obtain G to be equal to f r squared all over m1 m2. The dimension of G will simply be equal to, we take the dimension of F, we multiply by the dimension of R, which is squared. Then we divide this by the dimension of M1 times the dimension of M2. This will simply be equal to, remember this is the dimension for force. Force is the same as mass times acceleration, and this will simply give you the dimension of m l t to the power negative 2. So we are going to replace the dimension of F, which is force, by this. This will give us m l t to the power negative 2. We have to multiply by the dimension of r. Remember from the question, it has been mentioned that r stands for distance, so the dimension of r will be l. Then we square it. We have to divide all this by the dimension of m1, which is for mass, that means capital M, times the dimension of m2, which is m, since it is mass. Simplifying this will give us this m at the numerator will strike off this other m. We are going to obtain, when this m comes up, it gives us m to the power negative 1 times, here L is to the power 1 times L to the power 2, this will give us L to the power 1 plus 2, which is 3, times T to the power negative 2. Therefore, the dimension of G is simply m to the power negative 1 times L to the power 3 times T to the power negative 2. We underline the answer. Next, we have to write down the unit of G. The units of G is, we are going to replace m with the unit of mass, which is kilogram. This to the power negative 1 times, we replace L with the unit of length, which is meters. It is cubed, times, we replace T with the unit of time, which is second, the second squared. Therefore, the units of G is per kilogram meters cubed per second squared. Moving on to the next question, question 3. Question 3. For this question, it goes, a spherical object of radius r falls with a terminal velocity v in a fluid of coefficient of viscosity eta. The drag force acting on the object is related to its velocity by the equation F equal to K eta V R, where K is a dimensionless constant. Find the dimensions and units of the coefficient of viscosity eta. Take note, K is a dimensionless constant. First step, we are going to start by writing down the given equation, which is F equal to K times eta times V times R. Next step, we are going to make eta the subject of formula. That means we are going to divide all through by KVR. This will give us F divided by KVR is equal to K eta VR divided by KVR. Then we are going to obtain eta to be equal to, you'll see that at the right hand side, the K and K will strike off, VR will strike off VR, will be left with eta equal to F all over K V R. It simply means the dimension of eta will simply be equal to, take the dimension of force, you divide by the dimension of, we are going to leave out K, because K is a dimensionless constant. We divide by the dimension of V times the dimension of R. Okay, from the question, we have been told that V is simply the terminal velocity. That means V is velocity. We are going to insert the dimension of force. The dimension of force is simply given by, this is it from question 1. We have M times L times T to the power -2. We have to divide all this by the dimension of velocity. It is simply, this is it in question 1 again. What we have in the numerator here is L times T to the power -1. Then we multiply by the dimension of R. R stands for the radius of the object, and the dimension for radius is also distance, which is L. This will simply be equal to, you see that we can simplify. This L will strike off this other L, and this will give us M times, bringing up this L, it becomes L to the power -1 times T to the power -2 times, bringing up T to the power -1, it becomes positive. times t to the power 1. So this will be equal to m times L to the power negative 1 times t to the power negative 2 plus 1 gives us negative 1. Therefore, the dimensions of eta is simply m L to the power negative 1 t to the power negative 1. Now we can write down the units of eta. Units of eta, the coefficient of viscosity, is we are going to replace m with the unit of mass, which is kilogram. We replace L with the unit of length, which is meters to the power negative 1. We replace T with the unit of time, which is seconds to the power negative 1. Therefore, the units of the coefficient of viscosity is simply kilograms per meter per second. We are done with the solution of the following exercises for application on finding the dimensions and units of some quantities. If in case you have any questions or any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.